Hello, I welcome you all to this another interesting screencast. The problem reads the 30 pounds block A is placed on top of two nested springs A and B and C, and then pushed down to the position shown. If it is then released, determine the maximum height h to which it will rise. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by RC Hibbeler. So in solving this particular problem, we're going to use the conservation of energy principle. And let's determine the datum for our potential energy, gravitational potential energy. So this one is going to be our datum, like so. We do have the weight. We have the weight like so. Okay. And we have the spring force. Of course, we do have two springs there, so we'll say F. This springs, one is B, and then the other one is C. Right, so in solving this particular problem, like we said earlier on, we are going to use the conservation of energy, and we can define it by this equation. First, let me define this point as my point 1 and this one 2. Okay. So we have T1, okay, plus V1, and this is equal to T2 plus V2. So what is T1, or just T? T is the kinetic energy, okay, and V is the gravitational potential energy and the elastic potential energy. All right, so T1 for the block, which is the kinetic energy at point 1, of course, is temporarily at rest, and therefore this is just equal to 0. And then we have V1. V1, we have both gravitational and elastic, so we'll say V1G. Okay, V1G. This one here also, since our block is just in line with, or there is really, it is at the same position with the datum, therefore this is just going to be equal to 0. And then V1E, which is the elastic, this one we do have half KB SB squared plus half KC SC squared. And then we go to the other side, T2. This is the kinetic energy for the block at 2, point 2, or position 2. Since block A at position 2 is also temporarily at rest, therefore this is equal to 0. Then we do have V2, V2G, okay. So here we have is a positive value, which is just WH, and then V2E, okay, the elastic potential energy is just equal to 0. So let's replace everything. I will not include the zeros, so only have on the left hand side we have this, okay. On the right hand side we have that. So let's replace the values. So we do have half KB is just a 200, and then SB, that's a bigger spring. The displacement for the bigger spring is 4, okay. Then KC is 100, which is the smaller spring, smaller as in the diameter, its displacement is 6. Then this is just equal to, the weight is 30, then times h. So making h subject to the formula, this just becomes equal to, let's calculate, 0.5 by 200 by 4 squared plus 0.5 by 100 by 6 squared, then divided by 30. So our h is 113.33 inches. So this is the maximum height to which block A will rise. Okay, so I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.